Hi everyone and welcome to another PAT Problems video. My name is Helena and I'm the Access and Outreach Manager for the Department of Materials at the University of Oxford, and today we're going to be taking a look at question 12 from the 2012 PAT paper. So let's have a look. So this question simply says sketch the equation y equals 1 minus x squared all over x squared. Okay, so we've got a graph sketching question. So what comes to mind when I see a question like this? Well, we want to find out certain features of the graph that is going to help us sketch the graph. So what sort of features are these? Well, we might be wanting to find any stationary points. And not only that, we'll probably want to know the type of stationary point, whether it's a maximum or a minimum. And we also want to know what happens at various limits on the graph. So as x goes to 0 or x goes to infinity, y goes to 0, etc., etc. And we might also want to find out if there are any intercepts of the axes that might be helpful. Okay, so first of all, I'm just going to rewrite this equation. I'm going to divide through each term by this denominator because I feel like that might be helpful to us. So if I do that, I have y equals 1 over x squared minus x over x squared is 1 over x, and then x squared divided by x squared is 1. Okay, so we've rewritten our graph, our equation slightly there. So first of all, I'm going to look for any stationary points. And how do we do that? Well, we want to differentiate our equation. So to do that, I'm just going to rewrite this equation again so it's all on one line, because I find that easy to work with. So we have y equals x to the minus 2 minus x to the minus 1 minus 1. Okay. And let's differentiate that. So dy by dx equals minus 2x to the minus 3 plus x to the minus 2, and the minus 1 disappears there. So let's rewrite this as fractions. So we have minus 2 over x cubed plus 1 over x squared. Okay. And so for any stationary points, we want to set dy by dx to be 0. So at dy by dx equals 0, we have that minus 2 over x cubed plus 1 over x squared equals 0. Okay, so to help me figure this out, I'm going to factor out 1 over x squared from this equation. So we have 1 over x squared. I'm also just going to swap the terms around so we have the negative term on this side. So we have 1 minus 2 over x equals 0. Okay. So we can see that this equation goes to 0 either as x goes to infinity here, because then this is dividing by infinity, which goes to 0 there, or this term here goes to 0. So this one here is not very useful for our stationary points here, so let's focus on the term in brackets here. So 1 minus 2 over x equals 0. Let's do a bit of rearranging. So we have 1 equals 2 over x, and therefore x equals 2 at our stationary point. Okay, so let's substitute this back into our initial equation. So at x equals 2, we have that y equals 1 minus 2 squared, which is 4, all over 2 squared again, which is 4. And if we do the maths on that, we see that y equals minus 5 over 4. So here we have a stationary point at 2 minus 5 over 4. Okay, so now we want to figure out what type of stationary point this is, whether it's a maximum or a minimum. So let's have a look. So for that, we need to do the second derivative. So if we go back to our differentiated equation here, from there we can get the second derivative, so d2y by dx squared equals, try and show both at the same time, so we have 6x to the minus 4 minus 2x to the minus 3, and again writing that as a fraction, 6 over x to the 4 minus 2 over x cubed. There we go. So at this stationary point, so at x equals 2, what's our value of the second derivative? So d2y by dx squared equals 6 over 2 to the power of 4, which is 16, minus 2 over 2 cubed, which is 8. Okay, so let's just cancel this through. So we have the same denominator on the fraction. So we have 3/8 minus 2/8, which is 1/8, which is greater than 0. So therefore, if the second derivative of at our turning point, our stationary point, is greater than 0, we know it is a minimum. Minimum. So we have a minimum at this point here. Brilliant. Okay, what next? So what happens when we go to the limits of our graph? So let's have a think. So as x goes to 0, right, let's rewrite our equation so we can see it. So y equals 1 minus x squared all over x squared. Well, here as x goes to 0, well, we're dividing by 0 here, so we know that y is going to blow up to infinity. So when x goes to 0, we can see that y goes to infinity. And we can kind of figure out whether that's a positive or negative infinity as we look at the graph as we're going to sketch, and I'll explain it when we get there. And let's have a look as x goes to plus or minus infinity. What happens then? So as x goes to plus or minus infinity, well, let's rewrite our equation dividing through by the denominator again to have a look at each term. So here we have our equation. As x goes to either plus or minus infinity, well, we can see if we're dividing 1 over infinity, these terms are going to get incredibly small, so we can say that these become negligible. So as x tends to infinity, we can see that y tends to minus 1. So we have an asymptote here at minus 1 for the value of y. So I think at that point, we probably have enough information to have a crack at a sketch. So let's draw our axes here and label them with our x and our y. So what information have we got? So we have for y being minus 1, we know that x is going to tend to infinity, so let's just draw our asymptote there, so that's a value of minus 1. We also know that we have our turning point at a value of 2 minus 5 over 4, so let's mark that on here and label the points on our axes as well. And so because this is a minimum point, and we know that as x goes to 0, y goes to infinity, we can infer that this must be coming from the positive in order to get that to be a minimum. So we can draw the start of our sketch here. And we know that's a minimum point, and we know that y is going to tend to minus 1 as x goes to infinity. So we can see that it's going to taper off a bit like that. Okay, so where's the infinity going to come from this side? Is it going to be from the positive or is it going to be from the negative? So I always like to just check this. So let's pick a point here. Let's pick x equals minus 1. What's the y value? Is it positive or negative? So we have y equals 1 minus x, so we have a minus 1 for x, so that becomes a plus, minus x squared, so we are minusing 1 here, divided by x squared, or divided by 1. So we can see at this value, y equals 1, so y is positive. So we can see that this is going to come from positive infinity again, and tend to minus 1 there. So here we have our graph sketch. And if you had time, you could work out what the intercepts of the x-axes here are. You would end up solving a quadratic equation there. But for the purposes of the PAT question here and for our graph sketch, that's all the information you need there. So we have our sketch. So I hope that was helpful. And please join us for the next video where Kathryn is going to be taking us through another question from the 2012 PAT paper. We're going to be looking at question 18. Okay, so have a go at that, and I will see you next time.